Shalom everybody, Brother Nick here. Today is the second day of the first month, depending on where you got the spring equinox reading, which is the reason for this video. Today is March 22nd, 2025, here in Island of Cyprus. So, guys, I'm going to be talking about the international dateline, okay? So right now, like every year, there's a lot of confusion on who saw the straight line equinox reading and everything else. And especially this year in the United States, and you're going to find out there's a reason for it. It's because the international dateline actually split the United States into two parts, an eastern part and a western part. So it looks like, to me, this is my hypothesis, what I saw from what I'm doing here in this video is it looks like the western part of the United States, basically west of the Mississippi River, saw it on the 19th, while everybody else saw it everybody east of it on the East Coast, Eastern U.S., saw it on the 20th. So I'm going to go ahead and explain that possibly. That's one of the reasons why we have this confusion this year. I can't say that this is for certain. I believe it's so, and I believe that this is correct, but this is a hypothesis. Hey, if anybody wants to debunk it, go for it. But this is what I understand, and that's why I'm making this video, to present it and help bring some clarity to everybody out there and make this a little bit easier for everybody, because there's just so much confusion about this every single year, and we should have a better understanding by that now. And I'm just trying to get this done so everybody can have a easier, simpler understanding on this. So I'm going to be taking a look at the equinox event. The equinox event is when the sun is bisected by the celestial equator, and that happens at solar noon. And then from that location, we should be able to project where the international dateline, the solar international dateline for that year is. That means the head of the year, and also who saw the spring equinox first, which means that they're going to be the first to get the new year the following day. All right, so let's go ahead and get into this video. So that's what I made this video. All right, so now I'm going to go ahead and play a clip. And then after I play a clip of something that I recorded earlier this morning, then we're going to come back to the Gleason's Flat Earth map, and I'm going to discuss the spring equinox, the rotating dynamic solar international dateline. That's right. The international dateline is a solar calibrated dateline, not the Gregorian international dateline, which is a fictitious international dateline. We're going to be talking about the solar international dateline in this video. All right, so here we are on this spreadsheet that I created titled Location of Spring Equinox Event when the sun is bisected by the celestial equator. So the spring equinox event is when the sun is bisected evenly in half by the celestial equator, which is an imaginary line in the sky. And you can calculate the time that this event happens to the minute and to the seconds. That's how precise the math is now. So we have this information, and we're going to be able to use it to find and determine where the longitude, where this event happened. And it needs to be noted that the sun bisects the celestial equator at solar noon, someplace on the Earth. And that we're going to be looking for that location on the equator where this event happens on the Earth from year to year to year, from 2023 through 2026. Then we're going to plot it on the big flat Earth map, and then from that map we should be able to tell where the solar international dateline is, the dynamic solar international dateline. And the dynamic international solar dateline, that is the head of the year. That is the Rosh Hashanah. That is where the year begins. Those are going to be the first location on the Earth to get the full day equinox reading, the straight line equinox reading. And the following day is the first day of the first month. So those that get the sign first, they get the reading first, they are at the head of the year. So we're going to find out where that is. And that means we're going to find out who is the last to get the equinox reading on the Earth. And that this position, the head of the year, the solar international dateline, the head of the year, it rotates every solar cycle. Okay, so very important to note, all right, this is a 4-year pattern, and there was a leap day in the Gregorian year 2024. But what else I want to note is the time that it moves. It moves 5 hours and about 44 minutes or 45 minutes, depending. It's not to the second. So it moves, let's just say 5 hours and 44 minutes every solar cycle. Okay, so every tropical solar cycle, there's an advancement. The tropical solar cycle is 365.2422 days, and that 0.2422 of a day is 5 hours and 44 minutes, or 5 hours and 45 minutes, depending about. So that's what it moves every year. It advances every year forward. And I'm going to be displaying that on the azimuthal equidistant map. So here's the data. We're going to be looking at years 2023, 24, 25, and 26. All of this data is taken from timeanddate.com right here on their calendar and seasons, the solstices and equinoxes for UTC time. This is what the time that we want, UTC, okay? So we're going to get it from 2023 through 2026 right here. And then what we're going to do is we're going to plug it into this calculator right here, their World Clock calculator, and it's going to give us the position of the sun, the latitude and longitude of the sun. Okay, so here I am right here, March 2023, UTC is 2124. Let me go ahead and verify that right here. 2024 is where we're at. We're going to do this one first right here. So that's done. So I'm going to go ahead and hit change time. It's going to give us the location, the longitude of the sun. We're going to go ahead and cut this. And important to note, because we are looking for the spring equinox, which is when the sun is bisected by the celestial equator, that means the sun is on the celestial equator evenly, which is a latitude of 0 degrees north, okay, or 0 degrees. So it's always going to be 0 degrees latitude for the spring equinox event, because that is when the sun is on the celestial equator having the spring equinox, or the sun is bisected by the celestial equator on the day of the spring equinox. Paste it. Now 2024. Now 2025. 9:01 a.m. So that's where it happened. That's where the sun was at this year. And again, the sun's position is all on 0 degrees latitude at this time. As you can see, it says 0 degrees north, okay? Because this is the time of the spring equinox, and now this is for next year. Okay, now all of this data that you're seeing, we're going to 1446 for next year. All the data that you're seeing can be verified on the U.S. military, the U.S. Navy Naval Observatory website. I can't access the U.S. Naval Observatory website. I think it because there's a firewall because I'm in Cyprus or something. But yeah, you could go ahead and check it out there. Okay, so this is where the sun's going to be at next year. Again, 0 degrees north. So there you have it. Now that we have this information, time to go to the big Gleason azimuthal equidistant map. And we're going to go ahead and plot all of these locations on the flat Earth map. All right, so now that we saw that video, here is the Gleason map, and I want to talk about this map. I've plotted the spring equinox that you just saw for those 4 years, 2023, 2024, 2025, 2026. These are the locations of where they happened about, all right? And you can see the locations right here. This is 135, so this is 139 west. This is 139 east. So you're taking 0 right here, you're going east, 135 degrees right here for 2024. This year it was like around 47 degrees east. So here is 0, and we're going to go around to 45 and then come to 47. So this is where the equinox event occurs. The equinox event, when I talk about the equinox event, I'm talking about the equinox event where the sun is bisected by the celestial equator that I talked about previously. Okay, so now what I did was I made, with my children, last night we worked on making this. Now this is going to help explain the solar international dateline. This is not the fictitious fake international dateline that we have for the Gregorian. But what I got here is I'm going to go ahead and set this thing up, and it's going to line up to the date right here, and you're going to be able to see the international dateline coming through here. So, and that's how we're going to do it. But you can see it's going to line up here, and it's going to spin to 2026. And so what I'm projecting for the international dateline, it's going to be out here. So let me go ahead and put this on, and we'll be right back. All right, so got this posted up to the wall here, and I want to talk about this real quick. Okay, so we have the whole Earth. It's 360 degrees around. We all know that. All right, this is going to be the solar international dateline right here, this whole line. And we can, now I extended it with this stick so you can see it come down to here. But what I wanted to talk about with this is, don't pay any attention to this part yet, but there's 25%, and then this is all 75%. So the Earth that you see here is 75%, this is 25%, because, and that's because the international dateline rotates about 25% every year. The international dateline, it rotates about 25% every year. Okay, so that's what I'm going to be sharing in this video. So this again, right here, this is not for the daylight portion of the day. This is just to figure out where the international dateline is and who sees the spring equinox first. Okay, so that's that. But this one right here I made just to give an idea about the light of when the spring equinox happens. As you can see here on this Gleason map, here it is for the December winter solstice, what we call the winter solstice here. And look how here in the center, it doesn't reach the North Pole and it overlaps the ice wall, which is why they have the 24-hour... The Antarctic lands and the ice wall get the 24-hour sun here when this happens around December solstice. While here at the North Pole, in the Arctic here at the North Pole, they have 24 hours of darkness. This is when the sun is at the Tropic of Capricorn. Here, the sun has now moved past the equator all the way up to the Tropic of Cancer, and you can see that this is why you get the 24 hours of daylight at the North Pole. So there's nothing here on the spring equinox. You only have the June solstice and the December solstice, but I made this cutout. See how you can see it's kind of curved like this. This should actually reach out possibly to the side of the ice wall right here. So they get light and day. I don't have a piece of cardboard big enough to make this, but this is just to give an idea of how the sun, when the sun is on the celestial equator, the light that you can see as it rotates on the celestial equator. This is not the international dateline. That's not how it works. This is just the daylight portion. All right, so got this posted up to the wall here, and I want to talk about this real quick. Okay, so we have the whole Earth. It's 360 degrees around. We all know that. All right, this is going to be the solar international dateline right here, this whole line. All right, I'm going to move, and I'm going to spin it. I'm going to set it to 2024. I'm setting it to the spring equinox of 2024. And this is right here for 2024. And as you can see, what I did was, this 25%, this is where the international dateline would have been based off on this map. This isn't 100% accurate to the exact meridian, but it's very close. So you can see the dateline almost started at 0 degrees last year. This is where it would have been. It would have gone right through Europe, okay, Western Europe, right at the border of Western Europe, through somewhere on the west coast of Africa, and then out. So this is where the international dateline was started last year. That means that whoever was right here, west of the international dateline, in Western Europe, anything west of like 0 degrees basically, would have been the first to get the equinox reading last year. That means that they were at the head of the year. All right, so now I'm going to go ahead and change it to 2025. All right, I'm setting it to the spring equinox of 2025. Okay, rotating it to 2025 about. There it is. Here goes 2025. Go ahead and tape it down. So, with this reading right here for 2025, you can see this is where the sun was at for the equinox event, right here. So for this year, with the reading here at 2025, right here, this is the equinox. This is my hypothesis that the solar international dateline was at 86 degrees. 86 degrees west was the international dateline for this year. That means that if you were west of 86 degrees west, if you're west of this, you were the first one to get the spring equinox reading. This is where the day and the year would begin. You're the first one to get the spring equinox reading on this day. They would get it next. Pacific Islands, New Zealand, Australia, all the way down through Asia, to Africa, to Europe, and then finally the east coast of the United States. So everybody saw it here on this side on the 19th. The 19th was here. It hit the fictitious international dateline, which is at the 180th meridian. Right here, this is the fictitious international dateline right here, except they reach around some islands right here. But this is the fictitious international dateline. The date changed to the 20th. Everybody else is seeing it on the 20th. And then right here, the eastern U.S. sees it. So that means that everybody east of 86 degrees west, so everybody in this portion, and everybody in South America, and over here in eastern Canada, you all were the last to get the spring equinox reading on the 20th. You did not get the reading on the 19th. You should have really only gotten the reading on the 20th. Now, if you're very close to here, you could have got it on both days. You could have almost saw it on the 19th, but then also seen it on the 20th, because you're right here on the threshold of it turning, and so that's something else to consider. Okay, so there is a little buffer there, and there's a mix. So basically, it's about right there. So this goes through, so 86 degrees west is the cutoff. This is the solar international dateline for this year. That means that everybody around 86 degrees west, meridian 86 degrees west, everybody to the west of it saw the equinox on the 19th. It hit 180 degrees. Okay, and then the date changed. This is the fictitious international dateline. The date changed right here to the 20th, to March 20th. Everybody else saw it on March 20th, all the way down to where the international dateline should be. Now, this is my hypothesis on where it should be. It just makes sense because it rotates. Every solar cycle, the sun, the international dateline moves. It advances forward about 0.2422 of a day, okay, which is about 5 hours and 45 minutes. About 5 hours. So this is why I believe that this is where the international dateline compared to where the equinox moment is. So I hope that this helps you all make sense. This is my hypothesis on where to find the solar international dateline. There are some mathematicians out there. Maybe we can get Steve and Alonzo to code this so we can know exactly where the spring equinox event is. But this is it. This is plotted out here. It's this simple. And so this is the day of the spring equinox, that this is the reading for the 2025 spring equinox. The following day becomes the first day of the first month, according to the Psalm 19 solar calibrated calendar. And make sure you get my paper on this. I have a paper out on the solar calibrated Psalm 19 calibrated calendar. You have to get it. But this is how it's going to be. So their first day of the year was on March 20th, and the rest of the earth the 21st. Next year, for the 2026 Spring Equinox. Okay, we're going to just swing it. Next year we're going to swing it to here. Alright, right there. Alright, now let me go ahead and stick it. Alright, next year, Spring Equinox is going to be here in 2026. 180 is right here. Here's 180. So basically, unless you're living in these islands, you're not going to see it. You're going to see this on the 19th. Only the 19th is going to be here. Okay? They're going to get it on the 19th. The Spring Equinox reading on the 19th. It becomes the 20th. And basically the whole Earth next year is going to see it on the 20th. So this is going to be the whole year on this side. It's going to see it on the 20th. And on this side, it's going to see it on the 20th. Only between like, what is that, 172 and a half up to 180. So only that portion is going to see it on the 19th. So next year, everybody's going to get the Spring Equinox reading on the same date. March 20th, 2026. That's just how it works. So I hope that this makes sense to you all. I hope that you're blessed by the information in here. Please leave your comments. A lot of this is just hypothesis, trying to understand where this Spring Equinox reading is. It should be a lot more easier than what we've made it to be. It should develop a pattern and we can project it out. Okay, so I hope that you're all blessed, and I'm signing off, and shalom.